Hello guys, trust you're doing fantastic. Welcome to another lecture in digital logic. This is a very important topic I'm going to be explaining to you. It's titled Signed Magnitude Representation. This is very important in digital logic. Now there are two types of signed magnitude representation. The first one is signed magnitude form, and then we have the complement form. The complement form is nothing but the act of completing a particular expression. So this is what it's all about. Now the second part, which is the complement form, is divided into two parts. We have one's complement and then we have the two's complement. Now I'm going to be explaining this concept to you in a moment. Now let's take the first example. Now for example, to represent 7 in bits, 8111. Now you may be wondering, why is 7 represented as 111? Now we are trying to represent 7 in binary bits, in binary system. Remember, the code is 421, and this is the code. Remember this code. 1, the first digit, the first value is 1, meaning that 4 is present. The second digit or value is 1, meaning that 2 is present, and then you have the third value, which is 1, meaning that 1 is present. Now if you sum everything up, 4 plus 2 plus 1, it's going to give us 7. So this is the minimum number of bits required to represent 7 in binary number system. So this is how we got 111 to represent 7 in bits. Now this is the minimum number of bits needed to represent 7, just like I said. Now let's note some important information. All right. Now for sign representation in bits, 1 plus sign is represented as 0. Take note. Now the minus sign is represented as 1. This is very important. You need to take note of this representation of signs in bits. Now once you understand the simple logic, then the rest is very easy. Trust me. Therefore, the syntax for signed magnitude form is represented with this formula. Now, once you have this at the back of your palm, you have a column. You have these two columns. You have the signed bits, and then you have the actual binary. Now remember that the signed bit for plus is represented as 0, and the signed bit for minus is represented as 1. We know the actual binary bit for 7, which is 111. Now don't forget that. Now let's take this example to make things very straightforward. The example says, write the sign magnitude form of -7 and +7. Now, if we have to represent -7 and +7 in binary bit, it's going to be different. It's not going to be the same. So they don't mean the same thing when it comes to binary bits because of the sign. Now, in that case, we need to understand the basic formula. All right, so the first thing we need to do, now let's consider for solution, -7. Remember the syntax says you have two columns, you have the signed bit and then you have the actual binary. Remember, we're dealing with -7. The signed bit, the bit representing minus sign in binary is 1. The actual binary for 7 is 111. So therefore, using this formula like I explained before, to get 7, it means when you have 111, it means 4 is present, 2 is present, 1 is present. Sum everything up together, you're going to get 7. And then you have the sign bit, which is 1. It means -7, it's going to be 1111. So this is how we derive this answer. Now looking at +7, solution for +7, remember the syntax, which is a simple formula. Now you have the sign bit and then you have the actual binary. Now we know the sign bit used in representing plus sign is 0, so we write 0. We know the actual binary for 7, which is 111. Hence, therefore, +7 is going to be 0111. So you can see the binary representation of +7 is different from the binary representation of -7. So this is the answer for this simple exercise. Now I want to encourage you to pay attention to the subsequent videos in this channel. Alright then, enjoy this video. Bye.